So we are finishing the lesson from yesterday. Yesterday we talked about scatter plots and how to estimate the line of best fit by hand. Today, towards the end, I'll show you how to do that using Desmos, but I'll also show you how to do deal with something called residuals and how to do those by hand and by Desmos as well. There are some things like you need to understand the process. That's why we're doing it by hand, because that's how you would answer them on the test. There's like at least 4 questions on the test just about this. So the video for today will be posted here. If your friends are absent or on quarantine, maybe you want to remind them to stay caught up with the class, because that's the expectation when you're absent, is to stay caught up. And even just watching the videos, even just a few examples, is better than coming back and just expecting to know it by the time you get to the test. This bottom video down here will show you how to use Desmos for this unit as well. So watch that. That's how I learned how to do it. You can watch it as well and make sure you're ready for the test with it. The practice today is a Google form, and to prevent people from just randomly clicking through it, accuracy does count. All right, I'll give you like some leeway. If you get like 8 out of 12, I'll give you the full points. But otherwise, if you get less than that, I will take off a couple points for accuracy. You only get 1 try, so make it count. Don't just click through it. A couple important announcements, which is a repeat. I just want to make sure that the students that were absent hear this as well. There's only 2 tutoring days left. Yesterday we had tutoring, only 2 people showed up, only 1 of them got stuff done. That will improve their grade. Other one just comes because their dad makes them. All right, but there's only 2 more days left, and it's Thursday, May 6th and Wednesday, May 12th. So if you were trying to get your grade up, the sooner the better, because you never know, you could get quarantined and lose out on those tutoring days or lose out on those retake opportunities in class. So if you have the need to retake something, you can ask me anytime that I'm not teaching and I will let you, or you can come to tutoring. Those are the only days. Retakes and test corrections have to be taken in person, so there's no way around that rule. These we've already talked about, so just reminding you, 7 days from today, you're taking the Module 6 test. All right, and then 7 days from today is the deadline for late work from the pink folders. On Monday, I'll give you a missing assignment report, and that'll show you everything that's in that deadline. Questions? All right. So on page 3 of your packet, we're starting here. So page 3 of your packet. If you lost it, I do have some more that are on the back table. All right, but today, like I said, we're talking about what are called residuals. So that's the first blank right here. Residuals. Those are going to be the difference between the observed Y value and the predicted Y value. All right, so it's going to be actual Y value minus the predicted Y value. So the observed, or the actual Y value, is what you get from your scatter plot. It's the dots. Right? It's the data that you saw with your own eyes, that you calculated when you did the survey. All right? The predicted value is what you get from your trend line. All right? The one that's in Y equals mx plus b form. So the predicted values are what I get from plugging in like an x value and solving for y. So if the actual value falls really close to the trend line or is like spot on, then that's a really good value. But the scatter plot versus the trend line is how you find your residual. So it's the vertical distance from the actual plotted point to the point on the regression line. So if I'm talking about this point right here, I'm comparing it to where the line is for that same x value. All right, that distance in the middle is my residual. Make sense? All right, you can use residuals to tell you how good that equation is, how good that line of fit is. So we're looking at, is this line of fit a good representation of the data or not? So if you have residuals that are closer to 0, that would be a better line of fit. All right, that means there's no distance between the actual data point and the predicted data point. Questions about the vocab? All right, so then down here we have an example. They took the median age of women since 1970 for like each decade. So this is what they recorded for their data. So these are my actual values. That's what I get from the survey or the scatter plot. So these here are my actual values. My predicted values come from the line of best fit. So your predicted values are from your line of best fit. All right, so we're going to calculate the residuals, but first I need to figure out what my predicted values are. So how do you think we can figure that out? All right, maybe if I plug in the same x values that they have, I can compare them. All right, so notice here they did adjust the data a little bit. They put 0 as the year that they started taking the data, and then like 10 years after, 20 years after, 30 years after. All right, so we're going to plug in these x values into the trend line equation to see what my predicted y is. All right, we have the equation as 0.25 times our first x, which is 0, plus 29. So what is the first predicted y value? 29, right? Because 0.25 times 0 is 0, plus 29 is 29. All right, and then do the same for the next row. We have 0.25 times 10, that's our second x value, plus 29. What would that value be? 31.5. Good. Fill in the rest of the table using that same method. All right, I'll show work down here because I'm writing really big. All right, so solve for when x is 20, when x is 30, and when x is 40. All right, you can use a calculator. You don't have to make it harder on yourself. You can use Desmos. All right, what's this value? What's the predicted y when x is 20?
34.
34 exactly, good. What about when x is 30? 36.5, I got the same thing. And then when x is 40? 39. That is correct. All right, so here's the work for how we found these boxes, just plugging in the x's. Good on that part? So predicted y's you get by plugging in x. If I was making flashcards, I would make that a flashcard. The residual is what I get from subtracting the actual value minus the predicted value. And I put the formula up here for you. I'm not sure if I'll provide it on the test. I don't think I will. All right, because it's actual minus predicted. So the actual value when x is 0 is what? 29.2. All right, the actual value is what we get from the actual data. It's also here as well. 29.2 minus your predicted y. What's the predicted y? And what's the difference between them? 0.2. All right, so 0.2 is my first residual value. Would you say that that's pretty close to 0? Yes. So that's a good residual value to have. So next one, what's the actual value when x is 10? 31.3 minus the predicted value, which was good. And the difference between that is -0.2. Sorry, I have to write really big. All right, find the residuals for the next three. So the actual values minus the predicted values. All right, what's the residual for when x is 20? 34 minus 34, which is 0. So this one is 0. What about when x is 30? What's the residual? So actual minus predicted, 36.5 minus 36.5. Good. What's the residual when x is 40? -0.8. Because it's actual minus predicted, 38.2 minus 39. All right, questions on how we found that? All right, so memorizing that formula for residual, actual minus predicted. I think of it as like A comes first, all right, before P. So good on how to find predicted y and residual before we move on. Anyone need me to stay on this page? All right, so then now we're going to make what's called a residual clock. So those residuals that we had, so like when x was 0, the residual was 0.2. When x was 10, the residual was -0.2. We're going to record these coordinates onto this plot. And that'll be like a visual representation of our data, right? Like how good this line of best fit is. All right, so here's the residuals that we got from the first page. Just take like 30 seconds and plot them on this grid. So we have 0.2 and -0.2, 20, 0, 30, 0, and 40, -0.8. So looking at the plot, which ones are the best data points? Which ones are represented the best by that line of best fit? When x is 20 and when x is, and why are those the best ones? Because they're on the zero. Remember, residuals that are closest to zero are the best? Well, those are exactly zero. So the closer that these are to zero, the better those points are. So like, which one is the worst? This one, right? Because it's the furthest away. Now, all these are all still pretty close to zero, like negative 0.8 is still pretty close to zero. So I would say that this was a good representation of the data. If it was like all scattered, or if it was like really far away from the line, then I would say it's not a better fit. All right, so that's something that you can tell visually if you want to do that on your test. Questions about that? All right, so making a residual plot is one way to do it. I'll also show you another way next. So plotting these ones are the best. This one's the worst, but overall, this is a good representation. All right, so scrolling down, another way would be to calculate the residuals. So we already did that. We calculated the residuals. Squaring the residuals, adding them up, and seeing what that value is. If that value is closer to zero, then maybe like another line, then that would be a better line of fit. So basically squaring them, taking the sum of them, and seeing what that value is. So over here, here's the same residuals we calculated in the first example. We're going to square all of them and put them in this column. So what's 0.2 squared? .04. Negative 0.2 squared. Whenever you square something, it should be positive. So if you're getting a negative, make sure that you put it in parentheses first into the calculator. All right, 0 squared is, and then we have it again. And then negative 0.8 squared is 0.64. All right, so we squared them. Now we're going to take the sum of them, so that means to add them. All right, so add them all up. What do we get when we add them? 0.72. Would you say that that number is pretty close to zero? Yes. So that's a really good residual value to have. So I would say that this is a good representation of the data. So does the line fit the data well? Yes, because residual is close to zero. All right, what you'll usually see is you being given two lines. So like here's one line of best fit. You'll be given like another one. Let's say it's y equals 0.25x plus 40, right? And you'll be asked to figure out which one is better. Well, I would just square these residuals, and I don't know what it is. I'm just making it up. But let's say like I square those residuals and my residual value is 0.84. Well, which one is closer to zero? The original one, right? The 0.72. So this one is still a line, the best line of fit. All right, what if I changed it? What if it was actually 0.5? All right, which one's closer to zero? the green one, right? Because it's closest to 0. So that would make it a better line of fit. All right, questions? So here's a your turn, but I'll kind of help you set it up. So the your turn, that's on the next page. So we have completely new data. You guys are going to figure out the predicted y's and the residuals. So to kind of help you read this, we have predicted y's for this first line, so for the 2.24. I'm going to take what my x value is and plug it into this equation. So my x value is 2. It's going to be plus 2.4. What is that? 4.4. So my first predicted y value is 4.4. And I'll just do a row for you. How do I calculate the residual? What's the formula for residuals?
The actual y value minus the predicted y.
Good. So the actual y minus your predicted y. So what is the residual for when x is 2 for this one? What was my actual y value? Good, and you know because it's right here, also here. Minus the predicted value, which we said was 7 minus 4.4. 2.6, right? So that's my residual for this one. All right, now they already gave you the predicted y for the other equation. But we need to calculate the residual for that one. So what was the actual y value? And the predicted is what? 7 minus 4.2 is 2.8. Yep. But that's what you're doing. So fill in the rest of the table. The goal is to know how to come up with the predicted y's and the residuals. All right, so fill in that table, and we'll go over it in 1 minute. Yes, go ahead. All right, so we have the row 4, I'll call it because it's the one with the 4 as the x. What is the predicted y value for that equation circled in blue? So what was 8.4? That sounds correct. Let me just double check. Yes, that is correct. All right, you got that from plugging the x into this formula. So x is 6 plus 2.4 is 8.4. Good there. All right, what was the residual for that value? So what was the actual value? So 4 minus 8.4, which is negative 4.4. All right, so good. Now, what was your predicted y value for the green equation when x is 4? 6.2, that is correct. And then again, when x is 8, 10.2. So again, if you're not sure how we're getting that, we're plugging it into this equation. So like this box is 8 plus 2.2. All right. So the residual for that value, the actual minus predicted, what is the residual for that one? negative 2.2. Questions about that? All right, and then the work for this box, we have our actual value, which was 8, minus our predicted, which was 10.2. That's how we get negative 2.2. All right, so good. Now that we have those values, we're going to figure out which of them has a better line of fit. So the two equations were y equals x plus 2.4. I'll list all of those residuals. So 2.6, 1.6, negative 4.4, and negative 2.4. Sorry, I'm kind of writing over this. All right, and then the other equation, y equals x plus 2.2. Those residuals were 2.8, 1.8, negative 4.2, and negative 2.2. All right, so I just relisted them down here because we're going to use that method we just learned. We're going to square them, add them all up, and see which one is closest to 0. All right, we're squaring them to kind of get rid of that negative. All right, because just because you have a lot of negatives doesn't mean that that one is necessarily a smaller residual value. All right, so square them all. You can use your calculator. All right, what is 2.6 squared? 6.76. 1.6 squared. Good. Negative 4.4 squared. So anytime you square something, it should always be positive. So it's a positive 19.36. How do I get rid of that error if my calculator is the one that told me that? Parentheses. Good. All right, next one, negative 2.4 squared.
5.76.
Good. All right, now do the same with the green column. All right, what's 2.8 squared? 7.84. 1.8 squared?
3.24.
Negative 4.2 squared?
17.64.
And negative 2.2 squared.
4.84.
Good. All right, so all of these you can do in your calculator, just kind of making sure we're getting the right calculations. Next, we add them all up. So add them all up for each one. So like the blue side, when I add them up, I'm sure you guys could do that, so I'll save you some time. We get 34.44. When we add up all the green values, we get 33.56. So which line is the best line of fit? The one with the residual value of 33.56. So this equation. All right, because those residuals, when I square them and add them all up, are closer to 0 than the other one. So this one, because closer to 0. All right, questions, comments? All right, so there are some on your test that you do need to work out by hand, just like how we did here. So like if it says, which of these equations is the best line of fit? Or which one's better? What I'll show you next is how to do it on Desmos. So let me see. There's one more you try if you want to try it and check your answer on the whiteboard notes in Schoology, you can. I don't think I'll use time to go over it, but you can if you want. So I'm going to show you how to do it on Desmos now. And that's really helpful for some of the other problems that you're asked. So if you open up Desmos and you click this plus sign right here, so add item, I can add a table. All right, and I can put my data points, whatever they are, in this table. And I'm just kind of making data points up, all right, not really paying attention to what they are. All right, look, so now they're plotting all these data points for me. All right, so here's my data. I could electronically create a line of best fit. I just have to know what to type into my calculator. So here's what you can do, and this is something you would have to memorize. If you want to write it down on your paper, you can, because I definitely won't show you how to do this on the test. But this is a method. You are basically typing into this cell y equals mx plus b. But instead of typing that in, you type it into like a specific format. So you see how these are titled x1 and y1? You're going to type in y1, and then instead of equals, you're going to put this little squiggly line. It's on your keyboard somewhere. For me, it's like the top left. All right, shift this little squiggly line. And then mx1 plus b.
Will you provide that for us?
I will not provide you this. I'm providing it to you now. So if you want to use it on your test, you need to be familiar with it. You need to practice with it. All right, but this, once you pull it up, provides you some really good information. So like you see how it drew the line of best fit for you? It's always going to give you the best line of fit. It won't give you something like average. All right, it's going to give you the best one. So like over here, it tells you some cool stuff. It tells you what the slope is exactly. Right here, it tells you what m equals. It tells you what b equals. It tells you what that r value is. Now the r isn't for residual. It's the correlation coefficient. So if that's close to 1 or -1, that's a really good r value. So you see where it says residuals? If I click that button where that's underneath it, if I hit plot, now my residuals are plotted down here. You see them? Just like how we did them by hand, they're right here. So if they're closer to 0 or on 0, then they're really good. And it also even tells you what those values are. But it'll only tell you the values for the best line of fit. So if you're being told to evaluate one that might not be the best line of fit, and then you have to do those by hand. I don't think it'll evaluate other lines for you. All right, questions about that? All right, and then if you like play around with it, you know, maybe that'll help you memorize it better. But you do kind of need to know both ways for the test. All right, because there's some questions that are better with by hand, some that are not. So like, look, this one has data that is really on point. Right, the residuals are exactly 0 because they go through all the points. All right, make sense? All right, so I'll give you the rest of the time to work on your Google form practice. If you want to check out that last you try problem, the answer is in Schoology, so please ask me if you're confused. Otherwise, that's it.